Welcome to the deep dive. We're swimming in information these days, aren't we?
Oh,
Especially complex stuff.
definitely.
And new tech just pops up constantly, particularly in areas like medicine.
Mm.
So just imagine for a second. What if getting really advanced medical diagnostics was, well, as easy as just talking to someone?
That's a pretty powerful thought.
Mm-hmm.
And that's exactly the sort of intriguing question we're trying to get our heads around in this deep dive.
Yeah.
Our mission today is basically to give you a shortcut, a quick way to understand some really groundbreaking research. We're looking at a paper that explores how AI could make very specialized medical knowledge much, much more accessible.
And this isn't just some pie-in-the-sky idea. It's
Yeah.
actually quite developed.
Yeah.
We're diving into what is, I believe, the third version of this specific paper.
That's right.
It's called a conversational artificial intelligence-based web application for medical conversations. A prototype for a chatbot. So it's a real prototype, like a working chatbot built to help doctors.
And you can actually find it right now. It's available as a preprint on medrxov.org. That's the preprint server for health sciences.
Good to know.
Now, what's really exciting here, and sort of the engine behind this whole prototype, is something from OpenAI called function calling.
Ah, function calling. I've heard about that.
Yeah, it had actually just launched, right around when this paper was being written. And it's a big deal because it shifts these chatbots from just being, chatty to being really task-oriented. They can actually do specific things based on the conversation, not just generate text.
So this function calling thing, it's more than just a fancy feature. It sounds like it fundamentally changes how you can build AI tools, maybe even scale them.
Precisely. The AI becomes this smart orchestrator. It's not just talking, it's managing tasks.
Okay. So stick with us, because by the end of this deep dive, you're going to get some, I think, surprising facts and really clear insights into how this tech works. It's huge potential in healthcare, but also, the challenges it still faces.
Yeah, the hurdles are important too.
Definitely. You'll leave well-informed on this whole intersection of AI and healthcare.
So to really appreciate the solution they built, maybe we should first dig into the problem. Like, why do these super useful medical models even need a friendlier face to begin with?
That's a great question. Because you'd think if a model is good, doctors would just use it, right?
Mm-hmm.
But it's often not that simple.
Exactly.
It's almost like having, a medical superpower locked away because the instructions are too complicated.
Yeah.
Even the most brilliant models, the ones with amazing potential, often have this steep learning curve. A doctor, or whoever's using it, might need to understand really specific inputs and then figure out how to interpret these sometimes pretty obscure outputs.
And that's a huge bottleneck. It means lots of these high-utility models, well, they just end up stuck in academia.
Right.
They don't actually get into the hands of the doctors and nurses who could really use them day to day.
Which kind of brings us to this interesting comparison. Humans versus machines. Daniel Kahneman, the Nobel winner, he talks about noise in human decisions. Can you unpack that a bit? What does noise mean for, say, a doctor making a diagnosis?
Sure. Kahneman's noise basically refers to random variability in judgments, even when faced with the exact same information.
Okay.
So think about two equally qualified doctors looking at the same X-ray. They might reach slightly different conclusions, or maybe even very different ones, just due to this inherent randomness in human judgment. And yes, that absolutely applies to medical decisions.
I see.
Now, what's fascinating is comparing that to AI. Once an AI model is properly trained, it offers much more consistent, predictable performance. This paper and others show that models trained on expert data can actually show less variance than the human experts themselves.
Wow. So less randomness.
Less randomness, yeah. Which, could directly reduce the kind of variability that might lead to a misdiagnosis.
So while human experts are often really specialized, maybe narrow and focused, as the paper puts it, AI models don't necessarily have that limit. A well-trained model can handle lots of different conditions, maybe with similar accuracy, and it just keeps getting better with more data. Humans, well, we sometimes get overwhelmed by too much info.
That's a really key point. It hints at a different way to scale expertise. And it also ties into cost.
Ah, the cost factor. Right.
Training these big AI models initially, yes, that can be expensive. But once they're pre-trained, think like the models behind ChatGPT, they become incredibly cheap to run and distribute.
Okay.
So this paper suggests that the actual cost of intelligence, or at least this kind of analytical capability, might just plummet. It could really democratize access.
Which leads us perfectly into the solution proposed in this paper.
Mm.
This chatbot that acts like a smart shifter, or maybe a swifter.
Yeah, smart coordinator, basically. The goal of their prototype was to seamlessly connect these powerful large language models, the LLMs from OpenAI, with other more specialized models, like ones designed for reading medical images.
And the key is that function calling feature again.
Exactly. That's the breakthrough. The algorithm lets the chatbot intelligently figure out which external specialized tool or model it needs to use based on what you're saying.
And the user doesn't even need to know this is happening.
Nope. It all happens completely under the hood. You just talk to the chatbot naturally. You're not aware of all the complex switching and calling going on behind the scenes.
Okay, so it's like having a really smart concierge for medical data. You ask something, maybe upload an x-ray.
Right.
And the chatbot figures out, okay, I need the pneumonia expert model for this, gets the result, and then translates it back into plain English for you.
That's a great way to put it. And the paper uses this analogy of it being like a Lego system.
Oh, I like that.
Yeah, you can just keep adding new pieces, new specialized models for different conditions without having to rebuild the whole chatbot structure. That modularity is super flexible.
Very neat.
And this system, it gets triggered in two main ways. Either you upload an image, like that x-ray, or you send a text message, maybe with some medical measurements or symptoms.
Okay, let's make this concrete. The paper had a great example for the text input. Can you walk us through that? Say, someone worried about diabetes.
Sure. So imagine you type in something like, I've had some tests, want to know my diabetes risk. Female, 24, no hypertension or heart disease. BMI 35.42, HbA1c is 4, glucose 100. Something like that.
Okay, a typical kind of query someone might have.
Exactly. What happens next is pretty impressive. The OpenAI API, using function calling, pulls out the relevant bits from that sentence.
This parses the natural language.
Parses the natural language and turns it into structured data. In this case, a JSON output like age 24, hypertension, 0 heart disease, 0 BMI, 35.42 HbA1c level, 4 blood glucose level 100.
Wow, okay, it just extracts the numbers and conditions.
Yep. And they tested this too. They tried giving it inputs with all the needed info, some missing info, even extra irrelevant stuff to make sure it could handle it robustly.
That's thorough. And what about the image side? What models did they build?
For images, they developed two specific ones in the prototype. One looked at chest x-rays to spot viral or bacterial pneumonia.
Okay.
And the other analyzed OCT scans, that's optical coherence tomography, used for eye conditions like drusen, CNV, or DME, retinal issues.
Right, so after the specialized model, say the pneumonia model, gives its verdict, what then? Does it just spit out pneumonia positive?
Well, no, and that's the clever part. The chatbot takes that raw output and uses the LLM, again, the general language model, to craft a textual-friendly response.
Ah, so it translates the text speak.
Exactly. It creates a human-like answer. It combines the specific finding from the diagnostic model with its general knowledge to give you something understandable, maybe even suggesting next steps rather than just raw data.
It wasn't just about diagnosis, right? Did they add something about appointments?
They did. It was a sort of placeholder, a stub function, they called it. But it was designed to potentially schedule a medical appointment based on how severe the diagnosed condition seemed.
So you can see the potential there to link it directly into actual clinic booking systems down the line.
Absolutely. The foundation is there.
Okay, let's peek under the hood a bit more. What technologies do they actually use to build this thing, the tech stack?
Right. So for the web application itself, the part the user interacts with, they used Angular, which is based on TypeScript.
Why Angular? Any particular reason?
A key advantage they noted was that using Angular and TypeScript allowed them to kind of unify the development. They could use a similar language and framework for both the front-end app and potentially parts of the back-end logic connecting to the AI. It streamlines things.
Makes sense. And for the actual machine learning models?
Yeah.
The ones doing the diagnosis?
They used TensorFlow.js for the diabetes prediction model.
TensorFlow.js that runs in the browser, right?
Exactly. And that's a big plus. For the image classifiers, the pneumonia and eye condition models, they used Google's Teachable Machine. That leverages transfer learning, which is a smart way to build effective models without needing massive data sets from scratch.
So running models in the browser using TensorFlow.js, that means you don't necessarily need huge server power for every single user interaction.
Potentially, yes. It makes deployment more flexible, certainly. No heavy server infrastructure needed just to run that specific part of the model.
Okay, and the core AI brain, the OpenAI models. You mentioned function calling, but which specific models did they use?
They used a few different ones, actually. The paper mentions GPT-4 1106 Preview, GPT 3.5 Turbo 1106, and also GPT-4 Vision Preview.
Why so many? Do they do different things?
Yeah, think of them as having different strengths, speeds, and costs. GPT-4 1106 Preview is generally the most capable, the smartest one, especially good at handling those complex function calls and giving detailed, nuanced responses.
The premium option, maybe?
Sort of, yeah.
Yeah.
Often the most expensive, too. GPT-4 Vision Preview, as the name suggests, is specialized for understanding images, so that was crucial for the X-ray and OCT parts.
Got it.
And GPT 3.5 Turbo 1106 is usually faster and cheaper, good for maybe simpler conversational parts or less demanding tasks.
So choosing the right tool for each specific job within the chatbot.
Exactly. Optimizing performance and cost.
Now, you mentioned something interesting earlier that the paper noted. GPT-4 1106 Preview, refusing to make medical diagnoses, even when it had the tool.
Yes, that was a really crucial finding. Despite being given the function, the tool essentially, to call a diagnostic model, the GPT-4 model itself consistently refused to state a definitive medical diagnosis in its own response.
Why?
It's likely due to OpenAI's built-in safety guardrails and content moderation policies. It suggests a strong alignment, trying to prevent the AI itself from overstepping its bounds into regulated medical advice.
So it acts more like a cautious facilitator.
Oh.
It calls the expert tool, but doesn't claim the expertise itself.
That seems to be the behavior observed. It would trigger the function, get the result from the specialized model, but then present it carefully, often with caveats. It's quite different from, say, how it might confidently classify a picture of a snake if asked.
Interesting distinction. Were there other model quirks mentioned?
Yeah, they noted that the GPT 3.5 Turbo model sometimes struggled with passing empty parameters correctly, even when prompted not to. But the newer GPT-4 model handled that better, which just shows how quickly these models are evolving and improving.
And deployment. Where did they host this prototype?
They used Heroku. Pretty standard choice, known for being relatively easy to use, especially for applications built with things like Node.js, which often underpins Angular apps.
Okay. And one thing you touched on was the architecture being decoupled. The AI brain and the chatbot app are separate. Why is that a good thing?
Oh, it's a huge advantage for development. It means you could have one team that are experts in machine learning working on the diagnostic models,
Right.
and a completely separate team working on the user interface, the Angular app. They can develop independently, update things separately. It makes the whole process much more manageable and scalable. You can swap out models or update the interface without breaking the other part.
That makes a lot of sense for building complex systems. So let's talk results. How well did this prototype actually work in practice?
Overall, the paper reports that the integration was pretty effective. It mostly behaved as they expected, with just a few minor issues.
Okay. Like what worked well?
Well, the text-based path, the diabetes prediction example we talked about, that worked like a charm. It reliably pulled out the information from the text and triggered the diabetes model correctly.
Smooth sailing there.
Yeah.
What about the images, the X-rays and OCT scans?
Mostly good there too, but that's where they saw a couple of small hiccups. For instance, sometimes the system got the urgency wrong. It might flag a case of viral pneumonia as urgent, when typically it wouldn't be considered as urgent as bacterial pneumonia.
A nuance issue.
Exactly. And the pneumonia model itself had a slight bias. It tended to sometimes classify normal lungs as having pneumonia.
False positives.
Yeah, which the researchers acknowledged. They framed it as potentially a safer error for a prototype, better to overflag something for review than miss it, but definitely an area needing refinement.
Sure, you'd want to fine-tune that. But even with those minor points, the overall concept sounds really powerful. This idea of the chatbot as a hub or a toolbox for all these different medical models.
That's the core vision, yeah. It makes these really complex diagnostic tools accessible without the user needing to even know which specific model is running, let alone how to operate it manually.
It's a totally different user experience, isn't it? Moving away from clicking buttons and navigating menus to just having a conversation.
A much more natural, intuitive way to interact with complex capabilities.
And the potential impact on healthcare access seems huge, especially in places or situations where getting immediate access to a specialist is difficult.
Absolutely. Systems like this could really help to triage patients, reduce the load on healthcare professionals, maybe provide quicker initial assessments, and potentially improve patient satisfaction. Getting some information quickly can be very reassuring.
Yeah, definitely. But of course, with great power comes, well, the need for careful consideration, ethics, and limitations.
Crucial point, and the paper is very clear on this. The scientific viewpoint here is that these chatbots are meant to be assistants. They're tools for medical doctors, not replacements.
Okay, that's an important distinction.
They could be a great first contact point or a triage tool, helping to sort cases and gather information efficiently, but not the final decision maker.
And we have to accept they're not perfect. LLMs can be unpredictable sometimes, and as the results showed, the models do make mistakes.
They do, and there's a real danger if the wrong function calling happens or if the interpretation is flawed. That could lead to misinformation. LLMs are amazing language tools, but they're not always great at, say, complex logical reasoning or spotting subtle flaws in arguments.
So how do you guard against that?
Well, one strategy mentioned is training the models towards safer errors. Like we discussed with the pneumonia model, maybe biasing it slightly towards flagging potential issues for human review rather than missing them.
Better safe than sorry, essentially.
In a medical context, often yes. And also, crucially, providing very clear warnings and disclaimers to the user. Just like OpenAI does with ChatGPT, making it clear this is AI, it can make mistakes, it's not a substitute for professional advice.
Transparency is key.
Absolutely. But interestingly, the chatbot itself can also help reduce misuse.
How so?
By taking the raw, potentially complex output from a specialized model and translating it into that user-friendly response we talked about.
Right.
It prevents a non-expert user from trying to interpret and possibly misinterpret the raw technical data themselves. It adds a layer of interpretation and safety.
That's a good point. It buffers the user from the raw complexity.
Right.
And we should also remember, while we focus on AI errors, human medical errors happen too. They're unfortunately not rare and can be serious.
That's true. It's not about AI being perfect versus humans being flawed, or vice versa. It's about understanding the strengths and weaknesses of both. We're still learning how best to understand these mechanical judgments, as the paper might put it, just like we've studied human cognitive biases for years. This research helps build that understanding.
So let's sort of wrap this up. We've journeyed through this idea of a conversational AI boosted by OpenAI's function calling,
Yeah.
acting as a key to unlock these powerful specialized medical models, making them easier for people, potentially doctors, to use through just natural conversation.
Exactly. Taking complex diagnostics that used to be hidden behind difficult interfaces and making them accessible.
And that Lego idea really sticks, this modular approach where you can just plug in new diagnostic models as they're developed. That seems incredibly powerful for the future.
It does, and it ties into this broader trend of AI as a service, or AI.
AI.
Yeah, basically renting access to powerful AI models and the infrastructure needed to run them instead of having to build it all yourself from scratch. It makes deploying sophisticated models, like complex bioinformatics tools that used to need specialist researchers, feasible for a much wider audience, perhaps even directly within clinical workflows via a chatbot interface like this.
Makes these tools much more approachable.
Definitely more intuitive.
So here's a final thought for you, our listeners, to chew on. If conversational interfaces, like this chatbot, can make something as complex as medical diagnostics so much more accessible, what does that signal for the future of user interfaces everywhere, especially in specialized fields?
Good question.
Could conversation, just talking, genuinely become the new standard way we interact with complex systems and data? And if so, how does the role of the human expert continue to shift and evolve alongside these increasingly capable intelligent assistants?
That's definitely something to think about. Where does the human expertise fit in best as these tools get smarter?
A lot to consider there.